Hello students, welcome to Narayan BU College online classes. So today we are going to discuss about the solutions of your competitive exam of the chapter alcohol, phenols and ethers. Clear? See now question number 31. Question number 30. Clear? So direct reaction it is. So one is alcohol they have given and treated with sodium hydride. Sodium hydride is a base. So alcohol and base you will get the salt you will get. Clear? No? Sodium alkoxide plus methyl iodide you will get ether. Clear? No? So one thing simple this is, you know that if it is there is a alkyl halide, any iodide, chloride and bromide, whatever it may be, alkyl iodide and alkoxides are there. Clear? So this is instead of here R they have given here cyclic ring. They have given like this cyclic ring they have given. Clear? OMA. So instead of here RMe they have given here MEI. Clear? So this is sodium alkoxide. This is alkyl halide. And what is the reaction it is? Williamson's reaction. Here the Williamson's here the synthesis. What you will get now? You will get the compound is here and O, and what you will get now? CH3 and the NaI will be removed. So you will get the compound is that. That is only they have given reaction here. Clear? So what it is? Simple that is. If you observe very clearly, that you can easily understand that it is a Williamson synthesis reaction. So your option is option 4. Here Williamson alcohol synthesis reaction is there. It is not alcohol synthesis. This what we will call ether. So it is an alcohol. This is Williamson ether synthesis reaction. Clear? Next one. Coming to the question number 32. See here what they have given. Very easy question. CH3, CH2, CH double bond, CH2, CH2 double bond, CH2, HBr and H2O. You know what is this is? HBr and H2O. So addition of hydrogen halides on the alkene, because which one they have given here? Peroxide. Addition reaction it is alkene and HBr is there which reaction? Addition reaction it follows Markovnikov rule, either Markovnikov rule or anti-Markovnikov rule. But what they have given clearly, H2O2 peroxide, peroxide is there which rule it follows? You know, anti-Markovnikov rule. According to the anti-Markovnikov rule, negative charge will attach to the double bonded carbon where the number of hydrogens are more. So then what the compound you will get? CH3, CH2, CH2 and here CH2 Br. Bromine will be added here, hydrogen will be added here, double bond is converted into single bond. Clear guys? That is next one. Next one is this is Y and it is treated with C2H5ONa. Which reaction again it is? Again which reaction? You know, alkyl halide sodium alkoxide. What it is ma? Again it is a Williamson's reaction. Williamson's reaction means what will happen here? NaBr will be removed and here you will get CH3 and CH2, CH2, CH2 and OC2. This is your option. Clear? So then what is your option here? Option 1 is the correct. Clear? Next one. 33. Question number 33. Here. So same. First of all, see the reaction. CH3Br. Clear? And treated with KCl. You know, when alkyl halide treated with potassium cyanide, you will get the compounds are cyanide. If AgCl is there, isocyanide you will get. So that's why you will get the compound here KCl. Clear? No? That KCl is hydrolyzed. KCl is what? Hydrolyzed. You know, I already mentioned very clearly in the classroom. Whenever cyanides hydrolysis, you will get the compounds are acids. Clear? Cyanide hydrolysis, what will get? Acid. N will be removed as a ammonia, NH3. Clear? I already discussed, I will not go detail here. COOH. Clear? Plus what you will get? You will get N will be removed as a NH3. Acid cyanide hydrolysis, what is the product here? Acid. And after that, acid is there, then they have given here B, compound B. This is the compound B. A is this and B is this, and B now is treated with lithium aluminum hydride. I already said lithium aluminum hydride is a very powerful reducing agent. Clear? AAA process is there. What is the AAA process here? Alcohol oxidation, you will get aldehyde. Primary alcohol oxidation, aldehyde. Aldehyde oxidation, acid. The strong oxidizing agent is there. Alcohol are directly converted into acid. But here, acid is reduced to aldehyde. Aldehyde is reduced to alcohol. Strong reducing agent is there. Acid is directly converted into alcohol. So that's why this is the situation, because lithium aluminum hydride is a powerful reducing agent. So it reduces acids to alcohol. How many carbons are there? Two carbon alcohol means CH3 CH2OH. What we will call it is ethyl alcohol. So option 4 is the clear. Next one. See the question number 34. So many times we have discussed this type of questions in the classroom. Clear? And here following reaction. What is the major product? You will get two products here. One is the major and another one is the minor. So what is the product they are asking? Clear? So in this one, CH3, and you know CH double bond, CH2. Then what it is there? Hydrolysis in presence of which one? Acidic medium. In presence of which medium? Acidic medium. Clear? So you know that here alkene involves in the which reactions? Electrophilic addition reactions. Electrophilic addition reaction. First of all, and the electrophile will be added here. Clear? When it is added, what the compound you will get? CH3 and CH3, CH plus and CH3 minus. Because these bond electrons will sit here, this carbon is losing electron, acquires positive charge, partial positive charge, this is partial negative charge. Positive and negative, you will get the bond, CH3 and positive. Which carbocation here? Secondary carbocation. Clear? So now, you know whenever carbocation is intermediate, and if it is, there is a chance, they involved in the rearrangement, I already said. Clear? So it is a secondary carbocation. So one of this methyl group along with its electron, along with this electron means it is a negative charge, and it will come here. And it is negative charge means this carbon should get which charge? Positive charge. Next only that is CH3, and you know this is CH3, and here you will get what charge? Positive charge. And the CH here positive charge, CH3 is negative charge. Positive negative there will be a bond, and what will you get? CH3. Next what will happen, you see, this is which carbocation? Tertiary carbocation. This is which carbocation? Secondary. So which is most stable? Tertiary is more stable than the secondary. So that's why to get a tertiary more stable carbocation, this secondary carbocation involved in the rearrangement. Clear? So now we have to add which one? Water molecule we add. Water molecule means you already know it is positive, electron deficient, electron rich. Then there will be a bond it donates electrons. Then what do we get now? CH3, and OH, and OH hydrogen is losing electron, and here H and CH3 and CH3. Next time what will happen? These lone pair of electrons will move towards oxygen. Oxygen get negative, positive is then neutralized, and you will get alcohol. You know? So what is the option now here? Option 1 is the major. Next one, 35% direct question here, coal-based reaction. Clear no? So you know phenol, what is that one? Coal-based reaction, direct reaction. This is, you know what it is now here? Phenol is treated with NaOH and CO2 followed by hydrolysis. Clear no? Which reaction here? It is coal-based reaction. What is the product in the coal-based reaction? Salicylic acid, CO. So option 2 is the correct one. Next one, 36. 36 question, you already know that. Chlorobenzene reacts with magnesium in dry ether, give a compound A, which further reacts with the ethanol to yield. Very important question, this is chlorobenzene. Clear? What it is here? Chlorobenzene. Treated with which one? Magnesium and dry ether. Magnesium and dry ether. What is this reaction? Preparation of Grignard reagent. When alkyl halide react with the magnesium in presence of means dry ether solvent, you will get what it is now. You will get the Grignard reagent MgCl. Clear? So after MgCl, and treated this one with the which one? Ethanol. Ethanol means this is C2H5OH. Okay, you already know that. And ethanol is there, H plus O minus. It is magnesium plus, and it is which charge? Negative charge. When the bond breaks here, then negative positive and positive negative. Then what the compound you will get? You see, you will get the compound is here H and MgO C2H5Cl. This is the. So what you are getting here? Benzene. What you are for here? Benzene. Okay. So your option is option 2 is the. Okay. So next one, 37. Which is the maximum reactivity towards HCl? Clear no? HCl means you already know what it is here. Reaction with HCl. What is the compound they have given? Any compound, you know, ROH plus HCl. Then what will happen here? You will get the compound is first of all here. HCl means acid. Acid means what it is? H plus. The speed of reaction depends upon the stability of carbocation here. Why? Why? Because HCl means H plus. You know here what it is? Low pair of electron rich. It is electron deficient, and it donates the electrons to what it is? Electron deficient compound converted to what is positive. Oxygen is positive, so that's why it takes the electrons from R. Then what you will get? R plus. R plus means what it is? Carbocation. If the carbocation is more stable, then the reaction is very fast. Clear? So that's why which carbocation? First one, if you remove that, you will get allylic carbocation. Clear? So that's why first one is allylic. If I remove here CH2 double bond CH, CH2OH, if I remove here in the form of like this, I will get positive charge here. Next one. If I take here compound second one, CH2 plus, third one, secondary carbocation I will get, and plus, and what it is here? CH3. Next one is, you know, vinyl they have given CH plus. So which one is the most stable carbocation one? When it is allylic carbocation is most stable because it is stabilized by which one? Resonance, because you know positive charge. Double bond is separated by single bond, so involved in the which one? Resonance. When they are in conjugation, so that's why there is a chance of resonance. They involve in the resonance, so it is stabilized. Clear? Not compared. It is a, you know, primary. This is the secondary. Vinylic least stable. So your option should be option 1. Next one, 38. 38 question, direct question. Clear? No? See now, and they have given here CCH3 and here CH3, and they have given here bromine and the ethyl alcohol. Ethyl alcohol. Weak nucleophile. Weak nucleophile means what it is, man? If there is O minus is there, it is a strong nucleophile. O minus is there, what it is? Suppose if it is there, Na, then what it is? Na plus and O minus. Then minus is there, it is a strong nucleophile. But they have not given here O minus. It is what they have given here, OH. OH they have given means it is a weak nucleophile. Weak nucleophile is there, and it is a tertiary alkyl halide. Which reaction? SN1 reaction. SN1 reaction means what you will get the product here? You will get the product here is CH3, and CH3, HCl will be removed, and OC2H5. But if I take another reagent they have given here, what is the another reagent for here? CH3, CH2ONA, and in the ethanol OH. What is the reaction there also? Clear? You know that this is a strong nucleophile. Strong nucleophile means which reaction should take place here? It is strong nucleophile means SN2 reaction. Weak nucleophile means SN1 reaction. Weak nucleophile, SN1 reaction. Strong nucleophile means which reaction should take place? SN2, but SN2 reaction takes place with the tertiary alcohol? No. And SN2 reaction takes place with only the primary and secondary alcohol. So here SN2 reaction will not take place. If SN2 reaction will not take place, and you know all strong nucleophiles, means here strong nucleophile means it can also act as a strong base here. Strong base means which reaction takes place? Base means which one? Elimination reaction. So that's why here reaction is not a SN2. Reaction is a elimination. Elimination means what it is, man? Remove one beta hydrogen. This is alpha carbon. These beta hydrogens, 3 beta hydrogens are there. Remove here. Then what the compound you will get? CH3 and CH3 double bond CH. So your option should be option 3 is the correct one. Clear? Next one. What is the end product here? Clear? So end product they have asking question number 39. What is the end product they are asking? So here there is a bromine and here there is a chlorine and magnesium. Clear? So which reaction it is? Magnesium means clear? These are like aryl halides. Magnesium. Grignard reagent preparation. Grignard reagent means where it will Grignard reagent form. Here or here. Which bond breaks easily? There magnesium means Grignard reagent form easily. Bromine and chlorine, which bond will be weak? Bromine carbon bond will be weaker than the carbon and chlorine bond. It is small in size, it is bigger in size. When size is increasing, bond length increases, automatically bond strength decreases. So that's why Grignard reagent formed here. So here MgBr not with the Cl. Then what it is my D2O? D2O means what it is like H2O. B plus and OD minus. So here which charge here? Positive and here negative. Negative and positive. So you will get the compound here is this is the compound. And here there will be a D and here there will be a chlorine. So option 3 is the. So here next one 40th question. Experimental value of dipole moment is different from theoretical value in case of which one? Clear? Dipole moment means experimentally and theoretically you will get different values in which compound they are asking. Clear? You know dipole moment direction here. Fluorine is more electronegative than carbon, so dipole moment direction will be towards the fluorine. And here oxygen and carbon, oxygen is more electronegative, so that's why dipole moment direction is in this one. Both are in which direction? Opposite direction. Dipole moment will be 0? No, it won't be 0 because fluorine and OH both are different groups, so that's why. And you know magnitude of this direction will not be equal. So means it will have less cancel out dipole moment here. So that's why dipole moment decreases. Clear? Coming here also dipole moment here. This time dipole moment. Here totally it is cancelling. Just assume not totally cancel here, almost cancelling here dipole moments. But here what it is not exactly 180. But if you see here in this case there is a hydrogen bond. There is a hydrogen bond. So what it is actually, what is the dipole moment here? This is the dipole moment. You see there is a fluorine and here what is oxygen. Fluorine dipole moment direction is in this one and OH dipole moment direction is this one. If you add these two directions, what should be the angle here? The angle should be here 60 degree. Clear? As the angle decreases, you know automatically dipole moment increases because you see previous dipole moment directions are what is now both are in opposite direction. This is up, one is up, one is down. Up and down means what will happen? Almost cancel. Next one is 120. Previous like this, one is up, another one is down. Next one 120 and next 60 means they are coming close. Means adding here when it is coming to ortho, dipole moment is they are slightly adding to each other. If you take in this case hydrogen bond, due to this hydrogen bond, this OH and the F molecule they are coming close to each other. When they are coming close to each other, then automatically dipole moment will increases because this dipole moment direction also this side and it is coming this side. Both will be in the same direction, so that's why dipole moment should increase. Clear? So that's why here actually it is a theory. If you take in this one, don't consider the hydrogen bond and the bond angle will be here 60. If it is there OH, fluorine can form the hydrogen bond, so they will come close. So bond, automatically dipole moment increases. So in this molecule, we will get the theoretical value and practical value. Both are what is experimental value and theoretical value. You will get different. In case of which one? Low-cost reagent you already know. Next one is what is the major product here? Clear one? So major product they are asking direct question, simple I will say 42. So here in this case CH3 is there, Br. Clear one? So what it is here? Para bromotoluene treated with NBS. NBS means what it is? N-bromosuccinamide used for allylic or benzylic halogenation. Clear no? So that's why NBS means where the halogenation takes place. Benzylic. Benzylic means what is? Directly benzene attached sp3 carbon will be called benzylic, and here bromine will be there. Clear no? And next one. It is there, sodium ethoxide is there. This is alkyl halide sodium ethoxide. Either you will get. Clear one? So your option is option 2 is the correct one. It won't be replaced because this bond is which bond? It is not a single bond. It is a partially double bond. This bromine will not be substituted by the C2H5ONA. Only this one. This one will be substituted. So option 2 is the correct one. 43. You know, alcohol can be converted into aldehyde by using which one? Clear one? Alcohol should be converted into aldehyde. You have to use the mild oxidizing agent that we have already discussed. PCC is the best oxidizing agent to convert the alcohols to aldehydes. Clear one? So that is option 3 is the correct one. Denaturation of alcohol. I already mentioned in the class denaturation of alcohol. Clear one? Denaturation of alcohol means we will add the colored substances like to get that color. Alcohol should convert into that color. To get that color, we will use the copper sulfate. And sometimes what they will do, they will use this lavender alcohol for the drinking purpose. To avoid that, we have to add the PD to get the bad smell. Clear no? Pungent smell. So that is your answer. Option 2 is the correct one. Next one, 45. Question number 45. And they have given cresol. Cresol means and CH3OH group present on the benzene we will call it cresol, ordocresol. Salicylic acid COOH, and the fourth one is phenol. Fourth one is what it is here? Phenol. Clear? Now they are asking increasing order of the acidic character. You already know phenol acidic character, we have already discussed. And electron withdrawing groups are present on the benzene ring. Acidic character of the phenol increases and electron donating groups are there, and acidic character of the phenol decreases. You know that among these three, here which group is present? CH3 means what is it? Electron donating group. You know here COOH is a powerful electron withdrawing group. Clear? So that's why it is A, B and C. Which one is more acidic? B is more acidic, and here A and C if you compare, an electron donating group is there, electron donating group decreases the acidic nature. So next one it will come C, and last one it will come. This is the increasing order. A is having least acidic. Clear? Next one. 46. You have to match here. Column they are given. Methanol. Methanol we will call as a wood spirit. We will call as a which one? Methanol can also be called as a wood spirit because it is, you will get the methanol by the destructive distillation of the wood. So that's why we will call it as methanol. Coal-based reaction. Coal-based reaction means what you will get? You will get the salicylic acid. Option 1. Williamson's reaction. Williamson's reaction means what one? Reaction of alkyl halides with sodium alkoxide. 3. C should be matched with the 4. And conversion of the secondary alcohol to ketone. Secondary alcohol to ketone, what we will use? Copper. Clear? Copper and 573 Kelvin. Primary alcohols are oxidized to aldehyde. Secondary alcohols are oxidized to ketone. So what should be your answer here? Option 3 is the correct one. And the next one. Coming to the 47. Clear? Paracresol reacts with chloroform and alkali. Paracresol. Cresol means what I mentioned. If and OH and CH3 is present on the benzene ring, and those will be called as a cresols. Paracresol means it should be a both groups should be in the para positions. Clear no? So now treated with the chloroform and alkali. Alkali means what is the base? Alkali means what will get the base? That is, so which reaction it is? You know, phenol, chloroform and NaOH. Which reaction? Reimer-Tiemann reaction. Reimer-Tiemann reaction or not? Yes, so that's why in the Reimer-Tiemann reaction, what is the product you will get? You will get the product is salicylic, and here which one is this? Clear? So this is, you will get the compound A. Now compound A which adds hydrogen cyanide to form compound B. To this we are adding which one here? HCl. We are adding which one? HCl. HCl means here which group is there? Aldehyde. Aldehyde shall I write? This is my aldehyde. C double bond O H. You know HCl when we add H plus and Cn minus. Oxygen is more electronegative. Oxygen is negative charge and carbon gets which charge? Positive charge. Cyanide is negative charge and positive charge. There will be a bond, and here negative charge and positive charge, there will be a bond. Then what the compound you will get? You see, you will get the compound here is, one is what it is called OH, and here there will be a CH, and here which one? Cn. Cn will be added to carbonyl group. Then after that what they mentioned, you see, then carbox, you will get the later acidic hydrolysis gives chiral carboxylic acid hydrolysis. You will get what is hydrolysis? Just now I mentioned cyanide hydrolysis. What the compound you will get? Acid. So that's why this is the compound here. OH and here CHOH and here cyanide is there. What it is there? COOH. Is it chiral or not? Yes, it is chiral because it is attached to 4 different groups. One is hydrogen, OH, COOH, and another one is. So your option should be option 3 is the correct. Next one is 48. Which one of the following will show highest pH value? pH value highest means H plus value should be lowest. You know, acidic nature and pH will be inversely proportional. Clear? Because you know pH is equal to what it is? pH is equal to minus log H plus, or you can write log 1 by H plus. So acidic nature and pH value both are in which position? Inversely proportional. Clear? So that's why which is having highest value means which is a least acidic they are asking indirectly. Clear? Least acidic means I already mentioned in the classroom here. Suppose if I take 1, this is 2 and this is 3. So what is the acidic carbon? 2 is greater than 3 is greater than 1. This is the answer. Actually 3 should have more, 3 compound 3 should be more acidic than the compound 2, but due to here hydrogen bonding it is less acidic than the 2. So that's why 2, 3, 1. Which one is the least acidic here? Least acidic is compound 1. Least acidic means it will have the highest pH value. Clear? So how it is means it is already there in the PU class. You can go to that. Next one, 49 question. Question number 49. Clear? See the question number 49. Alcohol CH3 CH2OH treated with which one? Phosphorus and iodine. Phosphorus and red phosphorus and what it is iodine. I already mentioned it is PI3. Automatically it is a preparation of in situ preparation we will call. PI3 is unstable, so we should not add directly PI3 into the molecule. Before adding only it decomposes. So that's why this should be prepared itself in the reaction only. That we will call as in situ preparation. So alcohol and PI3, you will get what is alkyl halides CH2I. CH2 what is I. Next one, it is treated with magnesium. Alcohol means alkyl halide and magnesium. You know, dry ether, preparation of Grignard reagent, CH3, CH2, MgI. Clear? And the MgI is there. Then after that, this is treated with the formaldehyde. This is treated with the what is formaldehyde. I already mentioned Grignard reagent when reacted with the formaldehyde, you will get the primary alcohol. Grignard reagent reacted with the secondary, aldehyde other than the formaldehyde, you will get the secondary alcohol. Ketones is the tertiary alcohol. So that's why you already know how to mechanism, what is the mechanism here. This is negative charge and it will be attack here and this will go. So then what the compound you will get, and CH3, CH2 followed by hydrolysis, you will get the which alcohol? primary alcohol with the one more carbon atom. Then what the compound you will get here? N-propyl alcohol. I already clearly mentioned in the PU class work. So once you go through that, clear one? See. Now 50 question. IUPAC name you already know. First you have to give the priority for OH. So you have to give the numbering from the right to left. And chlorine comes alphabetical first. So that's why you have to write first chlorine name. 5-chlorohexane 2O. That is the answer. Next one. 51 question. Question number 51. So this is also we have discussed very clearly. Ethanol CH3CH2OH and treated with H2SO4. Treated with what is H2SO4. And it is I already mentioned it is a temperature dependent reaction. And if you change the temperature, automatically formation of products also changes. If I take 443 Kelvin, then you will get what is alkenes. You will get what is here alkene. If you take here dehydration reaction only. If you take 413 Kelvin and two molecules involved, you will get ethers. CH3 and here CH2, CH3. This is ether. So that's why what is our option? T1 is a 413, T2 is a 443 Kelvin. Option 2 is the correct one. Clear? Next one, 52. Question number 52. Phenol and zinc test. So it is there in the answer in this book. We have already discussed phenol and zinc. What it means? Zinc oxide will be removed and you will get what is benzene. You will get what is benzene. Next, this is the X. Clear? Benzene treated with CHCl3, AlCl3. What is this reaction? Friedel-Crafts alkylation. Benzene react with alkyl halide in the presence of AlCl3. What the compound you will get? You will get the compound is toluene. Clear? And toluene treated this one with KMnO4. KMnO4 is a powerful alkaline. KMnO4 is a powerful oxidizing agent, and it oxidizes CH3 group into what it is now? COOH. Even it is which compound is directly, which carbon is directly attached to the benzene, and that carbon will be oxidized to carboxylic acid. So your option should be benzoic acid. Clear? 53. Which of the following compound has more acidic? I already mentioned here. First you see, first option, third option and fourth option, all are aliphatic alcohols. Clear? But you see, option 2 is a phenol. Phenol is a which one? Aromatic alcohol. You know that aromatic alcohols are more acidic than the aliphatic alcohols. Why? Because of what it is? Stabilization of this anion. So after removing H plus ion, this phenoxide ion is get stabilized by the resonance. So that's why it can easily give the H plus ion. So more acidic. Clear? Next one. 54. Question number 54. Phenol reacts with bromine in CCl4. Clear? Phenol reaction with bromine and CCl4. Bromine and CCl4. We have two reactions and bromine in water. And bromine in CCl4 means what the compound you will get? You will get the compound is orthobromophenol and parabromophenol. Orthobromophenol and parabromophenol. But bromine water if you use, you will get what it is? 2, 4, 6 tribromophenol. So what is your answer here? Option 2 is the answer. So next one, 55, question number 55. Ether cleavage this is, you can easily identify. One is they have given anisole. What is the name of this compound? Anisole. Clear? And it is treated with HBr. It is treated with what is what? HBr. So what is the final product here? So cleavage of ether, you know which bond will break. And whether this bond or this we have to identify. This bond will not break. Why? Because you know it is a resonance with the benzene ring. So that's why it is a partial double bond character. It is a single bond character. So it is double bond breaking is difficult rather than what it is a single bond. So that's why this bond will break. So then H will be added here and Br will be added because O minus H plus. So what the compound you will get here is phenol plus methyl bromine. This is the reaction. So your option should be option 4. Clear? Next one, 56. Ethyl alcohols gives ethyl chloride with the help of. We have already discussed ethyl alcohol. C2H5OH should be converted into C2H5Cl. What is the best reagent for this conversion? You already know thionyl chloride, SOCl. Clear? So then why it is the best reagent and what is the product you will get when it is ethanol reacted with the SOCl2? You will get SO2 plus what it is not? HCl. You know HCl is a gas and SO2 also gas. So both will be, you know, they are evaporated, which escaped from the reaction mixture. You will get only one compound that is very pure compound. So what is the option one here? Option 1 is the correct one. 57. Dawes reaction involves. What is the Dawes reaction one? Preparation of phenol from the chlorobenzene. So here NaOH, you have to maintain very drastic conditions. I mentioned here, you know, pressure you have to apply and you have to heat this reaction above 600 degree temperature. Then what you will get? You will get the compound here is what you will get here? OH. So what is your option here? OH is replaced substituting Cl. So your option is nucleophilic substitution reaction. It is a which reaction one? Nucleophilic substitution reaction. Next one. Which of the following compound is most acidic? You already know how to do this one. You know, in case of 58, one option, nitrophenol. Phenol, nitro group is present. Then nitro group is which one? Electron, powerful electron withdrawing group. When withdrawing group is present on the benzene ring, and acidic character increases for the phenol. Next one. Last here 59. Question number 1 is here 59. Which of the following compound will most readily dehydrated? Most readily what it is called? Dehydrated. Means they have given 4 compounds. First one CH3, C double bond O, and here there will be a OH, and here this is the compound. Means dehydration means what it is here? First of all, OH here, suppose H is there. Here what is there here? It's anti-elimination, it is actually. H plus and OH minus should be removed, and water molecule will be removed here. Before that, first of all, which one will be removed? H plus. OH minus will be removed. OH minus will be removed means what it is? Positive charge will form here. Means in this reaction, dehydration reaction, which one should be eliminated here? Water molecule. Water molecule should remove first. Which one should remove? OH minus should be removed. OH minus should remove means then what you will get after removing the OH minus? You will get the compound is double bond, and here there will be a positive charge. Means the dehydration of this molecule depends upon stability of this carbocation. If carbocation is more stable, then it easily loses the OH minus ion involved in the dehydration very fast. Clear? But you see here positive charge is stability. You see here the charge is there, positive charge. Here which group is there? Electron withdrawing group. Electron withdrawing group means what it will do? It will withdraw the electron from this carbon. Then this carbon it is withdrawing. This group is withdrawing electrons from this carbon. Positive charge increases. Positive charge increases. Automatically what will happen? Stability decreases. So that's why it is a less stable. If you see compound 2 also in the same way, compound 3 also same, because OH is just beside the CO group. But option 3 you see, option 3 is this one, CH3, C double bond O, and here where it is there now, OH, and here this is. Clear? If you remove this, what you will get here? Positive. This positive charge is away from the electron withdrawing group. So compared to remaining 3, this is more stable. If it is more stable, then that molecule involved in the dehydration very fast. So what should be your answer, Maria? Option 3 is the answer. Last question. Alcohol KMNO4. Clear one? CH3, CH2OH. Alcohol KMNO4. Acidified KMNO4. KMNO4 is what? You already know. It It is a powerful oxidizing agent. Alcohols are directly converted into acids, not to the aldehyde. It will not stop at the aldehyde stage. So what you will get here? 2 carbon acid, that is COOH. Then treat this one with the B and H2SO4. You should get what it is, Maria. You should get ester CH3 COO and here CH2 CH3. Ester ethyl acetate should come. Acid ester means what you have to use? Alcohol. Esterification reaction. Acid reacts with alcohol and gives the what it is, ester. This is alcohol bond. What is alcohol bond here? Because CH3COO is there. This is means what should be the B? C2H5 OH should be the B. So then your option should be option what they are asking A and B. A is what it is, my acid and B is a alcohol. So this is about what it is, my solution for your competitive exam.